Hi and welcome to video 2 on this video series for Unit 4 Topic 5, Sampling and Confidence Intervals for the Math Methods course. So in this particular video I'm going to continue our sampling topic and look at statistical measures and some examples that take our work from last time further. We'll look at some other ways that we can collect random samples using our calculator. So we have a couple of statistical measures defined here on the video for you. The first one is the population proportion, P, and P is the number of members of the population with a certain attribute. And then we divide that by the population size, and that gives us a percentage or a decimal between 0 and 1 that represents our P. It's kind of like our probability of picking somebody with that attribute within the population. So for an attribute, will be something about the object. So we might not be talking about people, but if we're talking about people, it might be an attribute of do they have blue eyes or not. That would be the attribute, or are they left-handed or not. On the other hand, it could be objects. So you might be picking batteries randomly at a battery factory, and you're looking at are they 100% charged or not? Do they have a defect or not as the attributes. The sample proportion, which is P hat, when you got that little thing on top, that's called a hat. P hat is the number in the sample with the attribute divided by n, where n is the number of elements in the sample. So if you choose 20 and 8 of them have the attribute, then P hat equals 8 over 20. Again, a value between 0 and 1, or written as a percentage or a fraction. The number in the sample with a certain attribute is sometimes called X, and you'll see that referred to later on, so it's definitely worth knowing that too. So let's have a look at example 3. For the data collected in example 2, what was P, where the attribute is male? So basically there are 26 students, this is from the previous video. How many of them are male? If I go through and count, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. So we have 16 males in this particular class out of 26, and of course that means we have 10 females if that was part of the what we're looking for. So that's 16 doesn't contain a 2, 16 over 26. Your P hat, so P hat is a sample proportion where the attribute is male. So we go back up to the sample we chose, 2 of the 5 were male, so our P hat is 2 out of 5. What do we expect to happen to P hat as n increases? So we're talking about we take a larger sample. So the answer to this is, and I'd encourage you to pause your video and consider this before we go on now, but the answer to this is, as n increases, we'd expect to get closer and closer to the population proportion, which is P. We should be norming towards P. Now this is easy to see with a small population. So 26 students, if I choose a sample of 26, I will get a perfect P hat. It will equal P. If I choose a sample of 20, it should be pretty close to P. And so on and so forth. It should get closer. It's actually quite restrictive. The set is quite small, so it has to get closer. On the other hand, if you flip this around and look at a large population, it's a bit harder to see, but the truth is still there. The closer you get to the population, even if you increase from a sample of 10 out of a million to 20 out of a million, that should make your sample population better. Now, obviously taking a sample is random, so it might not make it better, but it's more likely to be better, and that's something we're going to explore more in this topic. So that's our little continuation there. Example 4 I can't do with you. This is set up for a class situation. So if I have 25 students in my class and they all take a random sample of the 26 students in the example of my class, then hopefully I can build up a frequency table. But the expectation, of course, would be that because my P value is equal to 16 out of 26, which is approximately equal to 3/5, if I'm taking 5 as a sample every time, and if all my students are, I'd expect most of them to get 3. I'd expect more, certainly, to get 3 than anything else. So I might have this many 3s, and I should have quite a few 4s still, and quite a few 2s. Like, you know, it's reasonable that I might not quite get 3, but I might get 2 or 4 instead. A couple of students might get all male, and a couple of students might get only 1 male, and there might even be 1 student who gets no males. But you can see here I'm expecting this kind of bump up, bump down distribution. And we're going to be exploring the shape of these distributions, and it doesn't look triangular like I've drawn, but I don't want to lead you towards that answer yet. And in example 5, I'm asking you to generate a random sample of 10 data points from a normal distribution with mu equals 20, sigma equals 5 using your calculator. And I've got the syntax and the methodology there: option, probability, rand, norm, and then put in your standard deviation, your mean, and then the number that you want in the sample. And I want you to determine mu and sigma of your sample. So I'm going to show you in the calculator a couple of ways to get the sample, but then I'll show you the second time will be the way that makes it easier to do the population statistics on it. So I'm already in here. I'll just exit back out. When you first click option, you should end up at this page. There, with list as your first option. You F6 across and go probability, random, and in this case we want a random normal probability, so it's more likely to pick something close to my mean. It should pick it in a normal sense. Now my mu is 5, my mean is 20, and I'd like a sample of 10. Close brackets, enter, and there are my 10 numbers. They're a bit of a pickle to see. I just need to scroll across: 22.96, 13.61, 18.09, etc, etc. What I can do instead though is if I go out my menu and statistics, if I go up to list 1 here, I can also do a probability random sample here as well. So I'm in my option menu and I choose probability F5 and random, and I do a normal random, and then I put in the same thing here. 5 is my standard deviation, 20 is my mean, and I'd like a sample of 10. Close brackets, I press execute. And you can see that the 10 samples have popped up inside here. Now what I can do with those values is if I go back up to there and exit back out to here, now I can do a calculation on those values. So I go into calculation and I can choose one variable statistics. I don't want two variables. I've only got list 1 there. But before I do that, I just need to check my set menu over here. Set tells me that when I do a one variable statistic calculation, it will use list 1. Now, I'm not worried about a frequency list. If you had a frequency table, it would be a number and then the number of times that one is chosen. I haven't got a frequency table, but I need to make sure it's the right list, which it is in this case. So I choose one variable statistics, and there they are. My mean is 18.82, and my standard deviation is 4.32. SX is my sample standard deviation, which divides by n minus 1 instead of n. And that's something that we'll cross later on as well. But for now, I'm just going to use my sigma x, 4.32. So there's my mu and my sigma for this data set. The data set was randomly chosen. Interestingly, my mu is 18.8. It's quite significantly below 20, but the standard deviation is 5. So it's not even close to one standard deviation below 20. So it's not too bad. So there you have it, taking a random sample in example 5. I've not written anything down, but I have talked you through it, and all the other work we've just done. And of course, if you are working from the Cambridge textbook and with me, there's the work that you should be doing with some detail about that. All the best.